Okay, so today we are covering Unit 2, Day 2 notes. So you should have done a play posit on Monday, and it talked about conjectures and counterexamples. And we are going to continue with that today with a little bit more into some sentences and some logic. And this is going to feel like not mathy. And the reason for that is we have to be able to use this logic when we are in the future doing like some proofs or some math. And we have to be able to use this logic. So this unit is going to feel very not mathy, and that's okay. Mathy is my coined word. Do you like it? Before we get too into it, though, I do want to just tell you that email is down. So if you have emailed me since, let's say, 4:45 yesterday afternoon, I have not gotten it. So if you're trying to email me and I'm not responding, it's not because I'm being rude. It's because I'm not getting it. So if you have an emergency, you're welcome to text me or call me. And you can find my phone number on our class announcements page. I put it up there for you if you have an emergency, you need to get a hold of me right away. Okay. I think OMHS is still working just fine. It's just the email that is giving us a hard time. Okay. All right. So these notes are available for downloading and printing on OMHS. House on fire? Call Mrs. Grandy. Maybe don't do that one. All right. So we're going to talk about statements, and there's a lot of vocabulary that goes with this, but we're just going to go through it one at a time. So in geometry, where's my pen? We're going to say that a statement is a sentence that is either true or false. If I'm saying that it's either true or false, that true or false is called the truth value. All right, and then our statement is represented using letters, usually P and Q, but it doesn't have to be P and Q. So if I have the statement P, and P is represented by supplementary angles have a sum of 180, what would its truth value be? That's a fancy way of asking, is this true or false? Supplementary angles have a sum of 180. Let's see, we'll make a poll because I think these are fun. Check mark for true, X for false. What do you think? Supplementary angles have a sum of 180. Supplementary angles have a sum of 180. Anyone else out there want to answer real quick? Supplementary angles have a sum of 180. Check for true, X for false. All right, well, this does tell me who is here and who isn't actually here. Nice. Okay. So if you said true, that's true. That's the definition of supplementary. A supplementary angle supplementary angles have a sum of 180. So that's true. So we would say T, truth value, or you could, write the word true if you really wanted. Being on the computer, this isn't such a hard time, but make sure you're writing your T's like T's, because, brick and mortar, I had some students that would like do this. And I didn't know what that was. Right, so make sure that you can read your handwriting. Make sure your T's look like T's and your F's look like F's. All right, now a negation is the negation of a statement has the opposite truth value. Okay, so shown by the symbol, and it's this little like squiggle. Okay, so this symbol right here means not P. So we're going to read this as not P. Supplementary angles do not have a sum of 180. So that's going to have the opposite truth value of P, so this will be false. if it's a T and a false, so you can say I said that's false true. All right, so there's some vocabulary for us. Now we're going to go into some conditional statements. Okay, so a conditional statement can be written in the form if then, and we're going to be using these like this whole unit. If then form. In symbols, it looks like this. If P, then Q. Okay, so it's this little arrow. And when you see this little arrow, you know we're talking about an if then statement. Okay. You could also think of it that P is implying Q. P implies Q. That P is called the hypothesis. So the hypothesis is the phrase immediately following the word if. And the Q, that is going to be our conclusion. The conclusion is, well, try writing that again. The conclusion is the phrase immediately following the word then. And we're going to see an example of this in just a moment. So a conditional statement is an if-then form. In symbols, you'll see it written as if P then Q, and there's really no symbol for if, but if you see that arrow, you know it's an if-then form. The P is the hypothesis that comes after the word if, and the conclusion is Q that comes right after the word then. So hypothesis, that's our P, conclusion is the Q. So here's an example. If you live in Nashville, then you live in Tennessee. Okay. So you find the word if, there it is. Immediately what comes after if, right up to the word then, that is going to be our P or our hypothesis. So I'm literally going to write, you live in Nashville. Don't use the word if. If is not part of it. You live in Nashville. The conclusion comes right after the word then. You live in Tennessee. Notice that I did not use the words if and then. If and then tell us where to look, but they're not part of it. So I'm not going to write the word if in the hypothesis, and I'm not going to write the word then in the conclusion. They're just telling me where to look. Okay, so let's look at number 2. If the sum of the measures of two angles is 90, then they are complementary angles. Right? That's a lot. But we can write it. I'm not going to use the word if. It's just telling me where to look. So here's if. So right after if, all the way up to the word then, that's my P. And I'm not going to use the word then. That's just telling me where to look. Right after the word then, that's Q, my conclusion. No matter what the sentence says, if you follow that process every time, you can do this every single time. This could be a whole bunch of nonsense words, but as long as you know to look after the word if and then after the word then, you'll be golden. So the hypothesis is the sum of the measures of two angles is 90 degrees. The conclusion, the exact phrase that comes right after the word then, they are complementary angles. Okay. Look at what you just wrote. Did you use the word if in your hypothesis? If you did, erase it or scratch it out. No word if in the hypothesis. Look at your conclusion. Did you use the word then? If you wrote the word then, scratch it out or erase it. There's no word then. Those just tell us where to look, but they're not actually part of the hypothesis or the conclusion. One more here, number 3. I want the hypothesis that comes right after the word if. So a quadrilateral is a square. Find your conclusion. I should have done that in green. Oh well. after the word then, but not including the word then. So it has 4 right angles. All right, so that's identifying our hypothesis and conclusion. Now I can take a sentence and put it into if-then form. So if I give you the sentence, an obtuse angle has a measure greater than 90, I want to write this in if-then form. So I know that my sentence is going to have to start with the word if, and it's going to have some words, and then it's going to have a then, and it's going to have some more words. I like to put this in what I call like Neanderthal speak. If obtuse angle, then measure greater than 90. Clearly, we don't speak like that. So you have to you might have to add a word or two to make it make more sense. If you're wondering, where do I put that word then? Okay, here's a little English lesson for us. Find the verb. An obtuse angle has a measure greater than 90. Here's our verb has. This is where then is going to go. If, okay, I'm not going to say if an obtuse angle. I'll say if it's an obtuse angle. Oh, I forgot the word and. Then it has a measure greater than 90. Okay, so find the verb, and that'll tell you where to put the word then. So Nishmia, what you just put in there is actually our converse, which we're going to talk about in a little bit. Yeah. All right, so looking at number 5, I want it to start with an if. So it's going to be if. Find your verb. All numbers divisible by 4 are also divisible by 2. Our verb there is are. Okay. Remember, a verb is like the action word or the doing word. So if, and we're not going to write all numbers. We'll say if the number is divisible by 4. Where am I? Then it is divisible by 2. And there are other ways to write this. So maybe you write it slightly differently. As long as you're having if divisible by 4, then divisible by 2. If you have words slightly different, that's okay. Lydia, what you just wrote there is actually the converse of my statement, and we're going to talk about that in just a minute. But that was a good question. Okay. I'm going to do number 6, and then we're going to move on from doing this. But it says states on the East Coast border the Atlantic Ocean. Border is my verb, so that's where the word then is going to come in. So I can say if the state is on the East Coast. See how I change it a little bit? I'm not changing the meaning. I'm just changing the wording of it so it makes sense in our English language here. So if the state is on the East Coast or coast, oh my goodness, then it borders the Atlantic Ocean. If you have to do this on an assessment, it would most likely be like a multiple choice. So you don't have to worry about like, do I have to spell it right? Or what if I do it differently, write it differently than you do? You would just pick the choice that best fits what the answer should be. I'm going to leave number 7 and 8 there for you to continue practicing on your own. Any questions about how to turn a statement into an if-then statement before we move on? Nope. Okay. Now, We have the conditional statement. It's an if then, but I could do things with that P and that Q and change the sentence slightly, which some of you were typing in the chat and asking me about. So you'll see that in just a second. Our conditional statement is an if then form, but I could also write the inverse, and the inverse is when I negate the hypothesis and the conclusion. So instead of writing, so this would be our conditional statement, if P then Q, I would write if not P, then not Q. Okay, remember that squiggle means not. I guess this by negating, not negate. Okay. The converse is formed by switching the hypothesis and the conclusion. So in symbols, that would say if Q, then P. And that's what some of you are writing in the chat over there with the obtuse angles. And we're going to see examples of all of these in just a moment. The contrapositive is formed by negating and switching the hypothesis and conclusion. And so in symbols, that would say if not Q, then not P. I would put a nice big star right next to this one because this is asked a lot. Like they'll give you a statement and they'll say, which is the converse? Or they'll give you a statement, which is the inverse? And you have to be able to identify the symbols and the sentence. And we're going to practice the sentences in just a moment. Okay, so put a nice star on this one. Maybe put them on some flashcards. Right, you're going to put inverse on one side of the flashcard. And on the other side, you're going to write not P, then not Q. On one side of the flashcard, you could write converse, and on the other side, you'll write Q, then P. Okay. So let's actually practice writing those statements. The conditional is given to us. If it is Saturday, then there's no school. Before I even start answering the question, I like to identify the P, the Q, the not P, and the not Q. So P, what is the hypothesis of this statement? What do you think? Go ahead and type it in the chat. What do you think is the hypothesis? Anybody? Thank you, Hannah, Lydia, awesome. Yes, and you guys who are typing it didn't even use, oh. Okay, I just want the hypothesis. Okay, so just the hypothesis, P, is it is Saturday. That's what I wanted to see. I think some of you just kept going. Wow, I can't, yeah, okay. So what's not P? If P is it is Saturday, then not P would be it is not Saturday. That's the opposite of it, right? Now let's look at Q. Q is, yay, there is no school. Good job. So what would not Q be? There is school. I didn't trick any of you. At least none of you typing in the chat. Okay. So I know it's weird. If you speak more than one language, sometimes this can be hard to like wrap your head around, right? Because like I know in Spanish, if we want to say there is not school, then we literally use the words not school, but in Spanish. But in English, when we have a not, we just get rid of it completely and say that there is school. So Q is there is no school. Not Q would be there is not no school, which sounds really weird. So instead we write there is school. Now we know what P, Q, not P, and not Q are. When you're starting to do this, I highly recommend writing the symbols off to the side for each one. So we know the inverse is not P, then not Q. The converse is not Q, or is P, Q, then P. And the contrapositive is not Q, then not P. Miss Grandy, how did you do that so fast? Well, I have them memorized. Okay. So now we have the symbols. We know what each symbol stands for, and now we can just write the sentences. So the inverse is going to be not P. So if it is not Saturday, then not Q. There is school. And now it's asking us for a truth value. What do you think? Is my inverse true or false? It's false. Okay. Right. If it is not Saturday, then there is school. Can you come up with a counter example? I'm seeing some of you put it in there. Sunday, right? So Sunday makes the first part true, not Saturday, but there is not school on Sunday. So Sunday is a good example of my counter example here. That's an A. All right, now let's write the converse. Converse is Q then P. So I find Q. Q is there is no school. So we write if, oh, I wanted blue. If there is no school, then, okay, and now I'm going to write P, it is Saturday. All right, what do you think? True or false? What's the truth value? False again. And another counter example could be Sunday again. You know, you could also think of like holidays, right? Like if there is no school, then it is Saturday. Like you could say, well, it's July. There's no school in July, right? So you could, or you could say it's New Year's Day. There's no school on New Year's Day or whatever. So if you thought of another counterexample, a day that we don't have school, but is also not a Saturday, that would be a contraposit, or that would be a counterexample. Yeah, I'm seeing a lot of good other counterexamples in there. How is it false? So if there's no school, then it's Saturday. Think of another day that there's no school. Sunday. Well, Sunday's not Saturday. That's why. Awesome. All right, let's look at the contrapositive. So contrapositive says, if not Q, then not P. So we're going to write if, and then what our not Q was, there is school. Then, and we'll write not P. Not P is, it is not Saturday. Good job, Arwa. Very good. This one is true. Good job, Brianna. I hope I said that right. This one is true. If there's school, then it is not Saturday. It doesn't mean that it's also not Sunday. It just means that if we have school, then it is definitely not Saturday. And when it's true, you don't need a counterexample because there isn't one. Counterexamples are to prove something's false. Okay, so the goal from this slide is, can you identify the P, the Q, the not P, the not Q, and can you write the inverse, converse, contrapositive based on the symbols that we just learned? Okay, that's the goal. Go ahead and try number 2. Identify your P, your Q, your not P, your not Q. If it helps you to write them down, definitely do that. If you can do it without writing it down, that's fine with me. I don't care, as long as you get them right. Write your inverse, converse, contrapositive. Let's do like 4 minutes on this, and then we'll go over it. And I am now locking the door, so if you get kicked out of class, send me an email. Oh, you can't send me an email. I'll try to remember who's here so you can get back in. I'll do my best. All right, try number 2. Do that now. All right, I'm just writing my answers up here and you can check with mine. I'll talk about it in just a second. Multitasking is not my thing right now, so let me finish writing this and then I'll talk about it. All right, thank you for those of you who are typing your answers in the chat. There's been a lot coming through, so if I didn't respond to you, please forgive me. You can check your answers on the board up here. This is why I said that maybe your answers would look a little different than mine. Maybe you chose to just write not odd. That's okay. You could have written not odd. So your inverse could say, if the product of two even numbers is not odd, then both numbers are not odd. And that would have been okay too. If you recognize that not odd means that they're even, then you could use the word even. Both would be correct. So a question like this, I would 100% make like a multiple choice or like a multiple select or something, because I would want you to be able to pick the right answer, and I wouldn't want you to get points off for writing not odd if I chose to write even, or if you wrote even and I chose to write not odd. Yeah, if it's easier for you to just write it on your paper, you don't have to write it in the chat. That's okay. Yeah, no problem. Okay, so your converse, it says if both numbers are odd, then the product of the two numbers is odd. And I was trying to write fast, so I used a little abbreviation. Hopefully you didn't, but that's okay if you did. And your contrapositive says if both numbers are even, then the product of the two numbers is even. Or maybe it says if both numbers are not odd, then the product of the two numbers is not odd. And that would be okay too. Yeah, it's a lot of writing. Yeah, it is. Okay, let's see. What do we have? I have another example here. For sake of time, I'm just gonna like say it out loud instead of writing the whole thing, because when I try to write fast, you can't read it anyway. Maybe I can type it. I'll do that. I'll try typing it. So first, let's identify our P and our Q. All right, so P is the temperature is 25. Then it is below freezing would be my Q. So not P is the temperature is not 25. And the not Q is the temperature is not below freezing. I like to write my symbols out here. Not Q, then not P, Q. Oops, I wrote that wrong. I'm jumping the gun. Not there. Not P, then not Q. Q, then P. And this one is not Q, then not P. There we go. Tia, isn't it crazy how they just all like go together? So let's write our inverse. I'm just going to type it so we can like actually read what I'm writing here. So the inverse is going to be if, of course, it's going to be on the line like that. Let me find. Okay, maybe not. Okay, if, okay, not P, the temperature, you'll see it in a minute, is not 25 degrees Fahrenheit, then, okay, and now not Q, it is not below freezing. All right. Our converse, come on, says switch the Q and the P. So it's still an if-then form. if, but now we're going to write what the Q was. It is below freezing. Then, and now we'll write what the P is. The temperature is 25 degrees Fahrenheit. And Nuro will not let me type those special little characters, so I just had to type out the word degrees. And the last one, the contrapositive. Whoops. Come on. Fine, be down here. Okay, it's still an if-then form. If, and we're going to write not Q. So not Q is it is not below freezing. It is not below freezing. Then, and then we'll put not P. The temperature is not 25 degrees Fahrenheit. All right, I'll move it in just a second. There we go. All right, any questions on how I wrote those? It literally does not matter what the sentence says, as long as you can identify your P and your Q, you can negate your P and your Q, and you can write those sentences in the different orders. This sentence could be complete nonsense, and I've seen that happen. I've seen, and this was a long time ago, back when I worked in Fairfax County, but I've seen tests have like, if it is a weeble, then it is a wobble, like complete nonsense words. And the only reason they put the nonsense in there is to see, do you understand the structure, not so much the sentence. I have no idea why they chose to use letters P and Q, but you'll see this in like every geometry textbook. You're going to see it say P's and Q's. And have you ever heard the phrase, mind your P's and Q's? Have you ever heard that phrase? It's kind of an old phrase. Yeah, that's where it came from. Mind your P's and Q's. Mind your hypotheses and your conclusions. Oh my gosh, it actually makes sense. I'm so happy. Yay. All right, let's move on. Oh, before we move on. We'll do yellow. Here's your attendance word. Your attendance word is inverse. Okay, your attendance word is inverse. Write that down. Inverse. Doesn't matter if it's capitalized or not. You just got to spell it right. And my goodness, you got to spell it right, guys. If you're spelling the attendance word wrong, you're not getting credit for it, and that makes me so sad. And I can't reopen it for you. So please spell inverse correctly. Inverse. Okay, once you have that written down, give me a check mark so I know I can move on. Inverse. Capital don't matter. No, capitals don't matter, just the spelling. I-N-V-E-R-S-E. All right, I've got 42 people that have it written down and are ready to move on. Or no, 28 people of the 42. All right, write it down. Inverse, 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 inverse. Just write it down somewhere or circle it on your notes or highlight it or make an interpretive dance to it real quick. All right, we're moving on in 5, 4, 3, 2, 1. All right, inverse. Let's move on. All right, with our conditional statements, we also have biconditional statements. Okay, remember bi means two. So we're going to have two conditional statements together. The definition of a biconditional statement is the conjunction, let me just write it. The conjunction, fancy for putting together, the conjunction of a conditional and its converse. In symbols, it looks like this. Double arrow. And you read it P if and only if Q. So when you see this double arrow, you're going to say if and only if. A biconditional statement is true when both, capital letters, that's important, both the conditional and the converse are true. Okay, and here's why we use double arrow. You know that the conditional statement is P then Q, and the converse is Q then P. So when we write it with the double arrow, P is pointing to Q, and Q is also pointing to P. So both the conditional and the converse together make that biconditional, and they both have to be true for a biconditional to be true. Okay. Let's practice some biconditional stuff. Okay. In this example, they're giving us the biconditional statement. We're going to pull it apart and we're going to write the conditional and its converse. Okay, and then we'll determine whether this biconditional is actually true. So what we're going to do is we're going to look at our phrase, two angles are supplementary if and only if the sum of their measures is 180. Find your word if and only if, and box it, circle it, underline it, highlight it, whatever makes you see it. What we're going to do is we're going to cross out that if and only if. That's going to turn into the word then, and then we're going to plop an if in the front. So our conditional statement is going to say if two angles are supplementary, then the sum of their measures is 180. Okay, I'm going to type it so you can actually read what I'm writing. I don't know why that's there. All right, so we're going to say if two angles are supplementary, then the sum of their measures is 180 degrees. I can't do a degree symbol, so you're going to see me write out the word degrees. If you're writing this by hand, you can definitely just put the degree symbol. All right, so what we've done is we've said that two angles are supplementary, that's the P. The sum of their measures is 180, that's the Q. So now the converse says just flip-flop those. So we'll write if, I'm going to be cheap and copy paste. If the sum of their measures is 180, won't let me. Then the two angles are supplementary. There it is. Okay, so when given a biconditional, you can rewrite it as its conditional and converse by finding the words if and only if, turning them into the word then, and throwing an if at the front of the sentence. So now you have an if-then statement. This biconditional is true if both the conditional and converse are true. So the conditional says if two angles are supplementary, then the sum of their measures is 180. Well, that's true. That's the definition of supplementary. And then if the sum of their measures is 180, then the angles are supplementary. Well, that's true again. So since these are both true, my biconditional is true. I don't know why I chose yellow. I hope you can read that. Yeah, so to go the other direction, Hannah, you're right. And do we do it? No, it doesn't have an example like that. If I wanted to go the other direction and make it a biconditional, you would find your word then. You would turn it into the words if and only if. and you would knock off the if at the front. So if you wanted to convert it back into the biconditional, you would turn the word then into if and only if, and then get rid of the if at the beginning. Yeah. Nice. Well, where to go? Okay. Why don't we practice number 2? Try number 2. I'll give you a couple minutes and then we'll go over it. And then I have 2 more examples after this. So let's do 2 minutes on this. Okay. So if your conditional says, if I wear my snow boots, then it snows, and your converse says, if it snows, then I will wear my snow boots, then you're right. What if you had those flip-flopped? You could have those flip-flopped because the biconditional, you can go both ways. So maybe the converse was maybe the conditional was if it snows, then I wear my snow boots. And the conditional was if I wear my snow boots, then it snows. You could potentially have them flip-flopped. You probably don't, and that's okay. Let's talk about the truth value. If I wear my snow boots, then it snows. What do you think? Think that's true? Yeah, that's false. If that was true, it would snow at my house all the time because my daughter loves her snow boots. They're blue with Elsa on them. So if she wore her snow boots and that's what triggered the snow, we would have like a winter wonderland in Virginia every day. So that's not true. Just because you're wearing your snow boots doesn't mean that it's snowing. So that conditional is false. Man, I can't remember the last time I wore snow boots. All right, converse. If it snows, then I will wear my snow boots. What do you think? Is that true? Maybe if I was going outside, right? This lady doesn't go outside when it snows. No, I stay inside all nice and warm. So if it snows and I wear my snow boots, well, I don't even have snow boots, guys. So that could be false, right? Maybe it's true. Maybe it's true for you, and that's fine. And it doesn't really matter here because I already have a false. So for that biconditional to be true, both of these have to be true. And since I already have at least one false, this whole thing is false. You're right. Some people wear normal shoes out in the snow. I have to wear normal shoes out in the snow. I don't invest in snow boots. Not in Virginia. Except 5 years ago when we got that 38 inches of snow. You remember that? I hand shoveled that too. Oh my. All right, here's a more mathy one. Yeah, I loved it too. I taught in brick and mortar. We had like a week off of school. All right, it says x squared equals 25 if and only if x equals 5. All right, so we know we're looking for that if and only if. It's going to get translated into the word then, and we're going to plop an if at the front. So our conditional is going to say if x squared equals 25, then x equals 5. And the converse, flip your P and your Q. If x equals 5, then x squared equals 25. What do you think? Do you think the conditional is true? If x squared equals 25, then x equals 5. Ah, Lydia, who said false? Someone said false. Faith, you're right. It is false. And Arwa, you figured it out. What about -5? Could x equal -5? Well, it certainly could, because -5 squared is positive 25. Yeah, if you weren't thinking negatives, that's okay. Now you are. So this is actually false. And the counter example is x equals -5. Okay, so this is false because x could equal -5. And if that happened, then x squared would still be 25. Now the converse, if x equals 5, then x squared equals 25. That's true because 5 squared is 25. But because I have one false, that means this entire biconditional is false. It doesn't say x equals 5. It's saying if x equals 25, then x equals 5. Okay, so it's saying that x squared equaling 25 means that x has to be 5, but it doesn't have to be 5 because x could be -5. Ah, here's a really good question. When you put a negative squared in Desmos, you get a negative square. And here's why. Okay, believe it or not, you're smarter than the calculator. I know you might not believe me, but it's true. If you have a -5 and you want to square it in Desmos or any calculator, you have to use parentheses. Because if you type -5 squared in your calculator is saying take a negative and then square the 5. But you don't want to take the negative of 5 squared. You want a -5 squared. And a negative times a negative, that's when you get the positive. So if you're trying to square a negative number on any calculator, make sure that you use parentheses. Yeah, I'm glad you asked that question. I'm so glad you asked that question. Thank you. Do you need to provide a counterexample for biconditional truth values? Not really. You just need to be able to tell whether they're true or false. And usually the way I tell something's false is by thinking of an example that makes it false. Yeah. Unless it might say, like, if it's false, give a counterexample. Then you would. All right, let's see here. Let's write the conditional and the converse. All right, John, I keep trying to let you back in. I hope that I'm catching you every time. Let's write the conditional. We're going to take our if and only if, turn it into the word then, plop an if out front. If I get 10% off, then I spent at least $75. That must be like a sale that's going on. What if it went the other way? If I spent at least $75, then I get 10% off. It says Faith right now. Yes, it is. All right. These are both true, right? Like whatever coupon, like I have a coupon and it says spend $75, get 10% off. Okay, well, if I got 10% off, that means that I spent $75. And if I spend at least $75, then they're going to give me 10% off. Oh, you want me to make the coupon? Here you go. Here's your coupon. I don't know. They probably put like money symbols on it, right? Spend $75, get 10% off. There you go. There's your coupon. How do you know there's a coupon? I'm going to guess because of the biconditional that tells me that this is happening. I will tell you that the truth value part is not super tested. It's the can you write a biconditional and can you translate the if and only if into the double arrow. That's what you really want. I really want you to be able to see, if you see this, you know P if and only if Q. And I want you to be able to take your if and only ifs and write it into conditional and converses. Those are the big ones. The truth value part is not super, super duper important. I mean, like it's a tiny bit important. But if you can identify that two arrows, meaning if and only if, you know it's a biconditional and you can write the conditional and converse, then you're good to go. Awesome. We got 5 minutes to spare. All right, that's the end of the lesson. Don't forget to do the exit ticket. Don't forget to do the attendance quiz. If you haven't taken the Unit 1 test yet, you need to do that by Friday. Okay? If you haven't taken the Unit 1 test yet, you need to do it by Friday because that is going to be marked as 0 on Friday if it hasn't been done yet. I gave the word. I can't re-give it. If you didn't hear it, you'll have to watch the recording. For those of you who are emailing me and say, I was in class, I watched the recording, what I'm going to do is I'm going to post a link at the end of the play posits. So once you complete the play posit at least once, you can click a link and you can fast forward through it as much as you want. I did. I gave the word. I already gave the word. Yep. All right. And I need to switch to my next session of geometry and do this all over again. I can't wait. I hope that you guys have a great day.